Hey guys, last lesson of the unit. Finally there. All right, solving equations using logs. All right, so today what we're going to do is we're going to take all the things that we have already learned in this unit about logs and how they relate to exponents and how we can manipulate them and expand them and condense them, and we're going to put them all together. So let's just quickly remind ourselves of some of the things that we have learned. Look at these warm-up. Okay, our first one says condense into a single logarithm. That means I'm going to end up at the end with just the word log and a whole bunch of stuff right here. Only one log though. All right, so let's work on condensing this. First, we're going to take our exponents. Remember, anything that's in the front is actually an exponent, and we're going to put it there. All right, so this becomes the log of a to the fifth plus the log of b squared minus the log of, and we could say c to the 1/2, but let's just go ahead and write it as a radical c. All right, now we need to check and see if we can condense this even further. So first step is looking to see if our bases are the same. These are all just logs, so yeah, they're all log base 10. So yeah, I can condense this. So addition here, which means multiplication. So this is going to be the log of a to the fifth b squared minus sign right here, which means division, divided by radical c. All right, on parentheses for clarity. All right, now I did, in the past, I have said, let's just go ahead and leave this guy as a radical. Let's go ahead, because it's a square root, and let's just rationalize this. So remember, when we rationalize it, we're going to multiply it by radical c over radical c. So then I'm going to get the log of a to the fifth b squared radical c over c. So this is my final answer. All right. Example number 2, expand the logarithm. That means let's pull it out. We're going to have a big ugly answer with one log for each piece. So I've got 1, 2, 3 pieces. So I'm going to have 3 logs when I'm finished. So the log base 3 of c, multiplication, so addition, plus log base 3 of d to the fourth, division, so subtraction, minus the log base 3 of f, and what's the cubed root as a radical? To the 1/3. All right, now we need to rewrite this. Still expanding, so let's bring the exponents out front. So I get the log base 3 of c plus 4 times the log base 3 of d minus 1/3 the log base 3 of f. All right, next, solve the logarithmic equation. Remember, when we're solving, we can only have one log or one natural log on each side of the equal sign. So I need to condense this left side here. So the first thing I do is make sure that I can condense it. Let's make sure they're the same base. Indeed, they are. They're both natural logs. So then we multiply the stuff together because this is addition. So this becomes the natural log. Let me actually write that properly, ln, instead of writing an h, of 2 times x minus 7 equals the natural log of x minus 1. All right, let's distribute this. So this becomes the natural log of 2x minus 14 equals the natural log of x minus 1. We have the same bases, so we set up the stuff, our y values equal to each other. So 2x minus 14 equals x minus 1. Bigger x is over here, so we're going to move this x over here. So minus x plus 14 plus 14. So x equals 13. And we need to go back to the original and plug it in and make sure that we don't have any negatives. So 13 minus 7, well, that's 6, that's positive. 13 minus 1, that's 12, that's positive. There's nothing to plug it in here, so that works. All right, now that we've got the warm up out of the way, let's take a look here. So solving equations with the same base. So our rule is that a to the x is equal to a to the y. If a to the x is equal to a to the y, then we can just say x is equal to y. All right, do you follow me? Same base, different exponents. The exponents are equal to each other. So let's look at an example here. Example A. 6 to the x minus 7th power is equal to 6 to the 3x plus 2 power. All right, same bases. So in effect, we can say the bases cancel out. We don't need them. Remember how when we were solving logs up here at the top, when they were the same base, we just did away with the base and just solved for the stuff. We're doing the same thing here. So x minus 7 equals 3x plus 2, and then we just solve for x. All right, I've got the bigger x here, so we're going to move this little x over here, so minus x. Move our numbers to the other side, so minus 2, so negative 9 is equal to 2x. Then x equals negative 9 over 2. All right, B, once again, same base, so the bases go away, set just the stuff equal to each other. So 4x minus 3 is equal to 2x plus 4. Big X is over here, so we're going to subtract the x's from both sides. Move that 3 while we're at it. So 2x equals 7. So x equals 7 halves. Same thing for C, same bases. So we just set the stuff equal to each other. So 3x minus 4 equals 4x minus 9. Bigger x's are on the right. Move our x's over there. Go ahead and move our 9 while we're at it. So 5 is equal to x. Well, that one was easy. All right, so far, so good, right? But what happens if the bases aren't the same? All right, the answer is fix them so that they are. I know you're saying, Ms. McMullen, how in the world do I do that? Well, let's think about it for a second, all right? You all know a lot about exponents, whether you realize it or not. So let's look at the first one. A, I have 9 to the x plus 1 power equals 3 to the 3x minus 5 power. These aren't the same bases, so I can't just set the exponents equal to each other. But can I fix this 9 so that it's a 3? All right, so let's think about it. 3 to what power equals 9? It's 3 squared, right? So I can say that 9 is equal to 3 squared. I didn't change the value, I just changed how it looked, right? So let's rewrite that 9 as 3 squared. So if I said 3 squared to the x plus 1 power equals 3 to the 3x minus 5 power. We now have the same basis. So we can set the exponents equal to each other. So then I have 2 times, because remember, power to a power is multiplication, x plus 1 is equal to 3x minus 5. Distribute, so 2x plus 2 equals 3x minus 5. Big X is over here, so we're going to move the 2x. Go ahead and move our 5. So 7 is equal to x. All right, let's look at another one. E. 8 to the x plus 2 power equals 2 to the 5x. E. All right, so let's look at the big one. 8. Can I write 8 as a power of 2? 2 to what power equals 8? Right, 2 to the third. So we're going to rewrite our 8 as 2 to the third. So 2 to the third power to the x plus 1 power equals 2 to the 5x. Now we have the same basis, so we set our exponents equal to each other. Remember, power to a power means multiplication. So 3 times x plus 1 is equal to 5x. So 3x plus 3 equals 5x. Bigger x is on the right, so I'm going to move my 3x. So minus 3x minus 3x. So 3 is equal to 2x. So x is equal to 3 over 2. Last one. So x, 10 to the x power, is equal to 100 to the 5x plus 8 power. Once again, not the same base. So can we rewrite the big one? Let's rewrite 100 as a power of 10. So 10 to the what power is 100? 10 squared, right? 10 times 10 is 100. So let's rewrite it. So 10 to the x power is equal to 10 squared to the 5x plus 8 power. Now that we have the same basis, we can set our stuff equal to each other, our exponents. So x equals, and this time let's just go ahead and do the distribution as we write it down. So 2 times 5x is 10x. 2 times 8, 16. All right, big x's are on the right, so let's subtract this x. Go ahead and subtract the 16 from both sides. Negative 16 is equal to 9x. So then x is equal to negative 16 over 9. See if I can clean that up a little bit. All right. And that is actually it for the day, guys. So not too bad. I'm sure you've all done really well. Hang on 1 minute. We've got some weirdness going on here. My pages disappeared and they're reappearing and weird stuff. All right. So let's look at this. Look at D. How do I go from 2 to the x to get to 1/2? Can I write 1/2 as a power of 2? How do I even get a 2 on the bottom? Negative exponents. So I could say that 1/2 is equal to 2 to the negative 1 power. See how that flips my 2 over? So 2 to the x power is equal to 2 to the negative 1 to the 3x plus 1 power. So now that we have the same basis, set the exponents equal to each other. So x equals negative 3x minus 1. This is negative, so my big X is over here. So let's add 3x to both sides. 4x equals negative 1. So we can say x equal to negative 1. All right, and everything else is more of the same. All right, so next up, what happens if the bases can't be the same? Can I make 5 and 6 be the same? No. So what do we do here? Well, let's figure this out. All right, so what do we do if I can't make the bases the same? Any thoughts? Okay, so what we're actually going to do this is we're going to convert them to logs, and then we're going to use the change of base formula. All right, so remember when we're converting to logs, we take this and this, we change it places. This is our x, it becomes the exponent. This reverts to a base. So I have the log base 5 of 6 is equal to 3x minus 2. All right, so now I need to change a base formula, right? Log of big over log of the little. So log of 6 over log of 5. One moment. All right, So now we've used our change of base formula, so we have the same base, and this still equals 3x minus 2. We want x by itself, so this works just like anything else. Scribble this out so it's out of the way. We're going to add 2 to both sides, so plus 2. So then we have the log of 6 over the log of 5 plus 2 is equal to 3x. And then we divide both sides by 3. But Mrs. McMullen, that's huge and ugly. Yeah, I know. Thankfully, your calculator comes with parentheses, and we can do this. So the log of 6 over the log of 5 plus 2 divided by 3 equals x. All right, so then we're going to plug this in. All right, I know, it looks nasty, but so judicious use of parentheses. So parentheses here and here. And remember, your calculator is going to want them here and here as well. All right, so we say, open parentheses, the log of 6 goes up parentheses, divided by the log of 5, close up parentheses, plus 2, close your big parenthesis, divided by 3, and then hit equals. All right, and this tells me that x is equal to 1.038. Remember, 3 decimal places and round. All right, so let's look at the next one. Let's look at B. Once again, can I make 9 into base E? Nope. So let's convert this to a log. So remember, change these places. This becomes my base. And base E means it's going to be a natural log. So we're going to say the natural log of 9 equals 5x minus 2. All right, and in this case, we're still okay, right? I don't even need to change a base formula. I can just solve this sucker. So, because I have a natural log button on my calculator. So I can say the natural log of 9, remember this, plus 2 equals 5x. Divide both sides by 5. So the natural log of 9, maybe I write it this way. Would that be better? Plus 2 divided by 5 equals x. And then we plug that into our calculator. Remember parentheses for your entire numerator. So open parentheses, natural log button of 9 plus 2, close that parentheses, divided by 5 equals, so x equals 0.839. So use parentheses, round to 3 decimal places. All right, we getting the hang of it? Maybe? All right, let's look at F. All right, can I write 15 as a power of 3? Now, I know you're thinking, but 5 times 3 is 15. Yeah, but that's not a power. That's being multiplied. That's not an exponent. So no, I can't. We're going to write this as a log. Remember, change these places. This becomes a base. I'm going to use some space over here for this. So I'm going to say the log base 3 of 15 is equal to x minus 2. Change your base formula. Remember, log of tall over log of small. Log of 15 over log of 3 equals x minus 2. All right, and then I'm going to add 2 to both sides. So the log of 15 over the log of 3 plus 2 is equal to x. All right, calculator once again. Log 15, close parentheses, divided by the log of 3 minus 2. It should be minus, Liz, it should be plus 2. Equals x equals 4.465. actually 0.464, but the next number is a 9, so we round up 3 decimal places and rounding. And that's really all there is to it, guys. All right. If you can make the base the same, make the base the same. If you can't make the base the same, change it to a log, use a change of base formula, and then solve for x. You will want a calculator for these. It's absolutely necessary. All right, if you have any questions, be sure you email me or send me a message through Canvas, and I'll see you soon. Have a great day.